Ladies and gentlemen, what is up, you guys? Guys, it's festive season, but hey, we are unstoppable. So today we're basically going to be talking about how to find the sum of an arithmetic series. Okay? Yes. So that's what we're covering: arithmetic series. Okay, arithmetic series sum. So that means that by the end of the lesson you probably know how to find the sum of the terms of any arithmetic series. Okay, and I'm going to quickly give you guys an example of a series. Right? Yes, meaning that you're going to see the pluses, right? 4 and then let's say 10 and then 16. Sorry about that. And 22, right? 22. So this is like how many times? 1, 2, 3, 4. Okay, and let's say up to okay, let's just say this is the we need to find up to 100 terms. So in other words, if you want to, you can actually carry on with the sum. You can see that from 4 to 10 we had to add 6, 10 to 16 we added 6 again. We keep on adding 6, right? It's an arithmetic series, so it does have some properties of an arithmetic sequence. The only difference is that here we've got the plus sign, right? That's what makes it an arithmetic series and not an arithmetic sequence. Right, but I believe, you know, within our arithmetic series we do have an arithmetic sequence. Okay, so this is what we have now. You need to find the sum of these up to 100 terms. This is very interesting. So that means you then have to expand this up to how many terms? 100. So far we only got how many? 1, 2, 3, 4. Just 4. So meaning that how many terms are we left with? Like 96 terms that we still need to write down and then sum them up manually with a calculator, right? So that would definitely be, you know, kind of tedious and all that. So but fortunately we've got a formula that we can actually use, right? We've got a formula that we can actually use. So, and the formula is as follows. If you want to find the sum of any arithmetic series, this is what we do. Sn is equal to n over 2, right, into 2a, right, plus n minus 1 times the d. So that's your formula, okay? And the n is basically the total number of terms. Okay, so let's write it down. N is equal to total number of terms, and the d is still a constant difference. And what else? The a, it's just first term of the sequence of the sequence. All right, so now you already know how to find the d, and the total number of terms, I think it's right there, right? I hope you guys can see it. total number of terms. That's 100. So we already know our n is equal to 100. And also we know that the first term is 4, and the constant difference, right? 10 minus 4, 10 minus 4, that's 6. 16 minus 10, that's 6. So the constant difference is basically 6. So let's go to the formula. Let's rewrite the formula. Remember, the formula says the sum of the arithmetic series is given by what? N over 2 into 2a plus n minus 1 d. Okay, d. So then we do the substitution. We know that n is 100 over 2 into 2 into a. What is the a? That's 4, plus the n is 100, right? 100 minus 1 times the d, which is what? 6, isn't it? I believe the d is 6. And then we punch everything into our calculator and we'll be able to figure out what the sum is. Okay, 100 over 2, that is 50, isn't it? 50 times 2 times 4, that is 8, plus 100 minus 1, that's 99, times 6. Okay, times 6. I hope you guys can see there. Okay, so let's see what the answer is going to be. The answer is 30,100. Okay, that is our answer. So that means that if you sum the numbers from term number 1 like that up to term number 100, you'll get this large number here, 30,100. Okay, and now I'm gonna ask the question slightly differently. Okay, just a second, there's something that I want to figure out. So 4 plus n minus 1 times the 6, so that becomes 6 minus 2. Okay, that's fine. So I want us to check, what if we ask the question slightly differently, right? What if we ask the question slightly differently, and they're saying, okay, you are given this, right? You're given 4 plus 10 plus 16 plus 22 plus up to term number 598, right? So now they're saying we must sum all these numbers, right? We must find and this is the last term. Do you understand? We're given the value of the last term, but we don't necessarily know what the n is. In other words, the total number of what we call the total number of terms within the series. You understand? Now there's a special formula for that if the last term is given, right, which is Sn, right? The sum is given by n over 2 into a plus L, right? A plus L. Okay, so but we'll still need the what we call, we still need the n, right? But this is kind of like a shortcut, right? Because you can see that here you don't necessarily need the d. Do you understand? The d is not necessary, so you won't have to substitute the d. So but you do need the n. So that means now you'd have to figure out, okay, what is the position of the last term? Then you substitute it up there, right? So to find the position of the last term, definitely you need to use what we call, you need to find the general term first. So a plus n minus 1 d, right? And then we know the first term is 4 plus n minus 1, and then the d is 6, right? And then our answer becomes 6n minus 2, which is equals to 598. So n is going to be 100, right? So we know that, okay, if we've got the position for this, we can simply substitute, okay, in place of the n, that's just going to be 100 over 2, right? 100 over 2 into the first term, which is 4, plus the last term, which is 598. And this should give us the same answer that we got over there, which is 30,100. So that's like 50, right? It's 50 into what? 50 into 4 plus 598. 598. And we're getting the same answer, that's 30,100, right? 30,100. So meaning that it's very important for you to know both formulas, because in fact when this is the case, they'll probably tell you the position of the last term to make things easier for you, understand? Then in that case you won't have to actually look for the position using this, right? So it's very important that you know both formulas so that you don't have to, because sometimes you'll be surprised, why are the marks so low, right? But you don't understand that you're not using this formula, but you're actually using this one, which is way much, you know, faster compared to that one. So you just need to check the situation and figure out what formula you need to use. But you can actually get away with using this one all the time. So this is like the main formula, you understand? So yeah, if you feel like you don't understand this one, it's not a train smash, you can stick to the other one and you'll probably get it right, you know, almost all the time. It's just that if you want to, you know, master this whole thing, then you gotta know this one as well, so that you you just do the KO thing, right? You just KO the question when it comes, because the most important thing is to actually, you know, ensure that you don't spend too much time on a single question, right? You're able to, you know, get the answer within a couple of minutes, and then you move on to the next question. So we've looked at that. So sometimes you're given this, okay, find, sometimes this is what's given. So let's see. Yeah, sometimes you're given a question like this. They say, okay, evaluate, okay, evaluate the sum n is equals to 1 up to 100 of 6n minus 2. You understand? So this is the question that you're given. They ask you to evaluate. In other words, find the sum. By just looking at the general term, you can see that it's linear. So meaning that this is an arithmetic series. you can see from the sum sign that this is a series, right? Because the sum, it's not a sequence, it's a series. So it runs from n is equals to 1 up to n is equals to 100, right? So in other words, we're dealing with exactly the same thing that we dealt with that side. It's just that this time around, this is now written in segmentation, and would solve it exactly the same way that we solved, you know, the other one, right? So now, if the position for the last term is given and you already have the general term, you can actually find the last term. So last term is going to be given by 6 into 100 minus 2. You understand? And that's going to be 598. All right, because remember 100, that's the position for the last term. Okay, and then 99, the position for the term just before the last term, so on and so forth. So now if you've got the last term, guess what formula we're going to be using to find the what we call the sum. But obviously, if you're going to be using this formula as n is equals to n over 2 into a plus l, right? As you can see, we're also going to need the a, which is the first term. So to find the a, obviously that means you need to substitute 1, because the position for a, that's 1. So a is given by what? 6 into 1 minus 2, which is what? 4. All right, so we've got the first term and the last term now. And we also know that our n is equal to 100, because that's the total number of terms in the series. Do you understand? So meaning that we're ready to then substitute. Okay, we're ready to substitute. So n is 100 divided by 2, right, into a, that's 4. The last term is what? 598, and that would give us what? 30,100. So, but I mean, remember what I said. This formula works all the time. It's just that sometimes it's kind of long. So this is the case. It's 2a plus n minus 1 times the d. So let's see how this formula would work out. So with this formula now, we need to figure out what the d is. Okay, we need to figure out what the d is from from that. Okay, and obviously whatever that's attached to the n, right, whatever that is attached to the n, that is our d. Okay, so d is equal to 6, whatever value that is attached to the n. So now if d is equals to 6, then what is we also know that n is equals to 100, which is the last term. And what else do we need? We need the a. A would just, you know, do exactly what we did over there. 6 into 1 minus 2, then we get our 4, and then we do the substitution. So now this method or this formula, you know, prolongs the process, because now look, we had to go as far as finding the d, and when there's too many processes involved, you guys know what happens. Most learners don't get it right. So that's what I'm saying. This formula, it's easier to use. It's just that it doesn't work all the time, because sometimes you don't have the value of the last term. And here you can see that you don't necessarily have to find the last term. So now this becomes what? This becomes 100 over 2 into 2 times the a, which is 4, plus 100 minus 1 times the d, which is 6. And this is still 30,100. And ladies and gentlemen, that concludes today's lesson. Hope you guys enjoyed, and any questions, please drop them in the comment section. I'll try to respond as prompt as possible. And yeah, I hope you guys are enjoying the festive season and all that, if you're watching this video during festive season. And don't forget to like, so that YouTube can push the content to as many people as possible. I'm still gonna drop more videos, sharing the love and all that, because this is how I express my love to you guys, by giving out more and more math content. So this is not the end of it. We're still gonna tackle more arithmetic series questions. So this was sort of like just an introduction into how to use the formulas for series. We are also going to talk about how the formulas are actually derived, so don't stress too much about that. We're still going to look into it without wasting too much of your time. Goodbye for now.